something that we're going to be using periodically is the idea of rationalizing the denominator. You can also do this to the numerator. And primarily in algebra, we've been using it to the denominator. Calculus, we do the opposite direction. But we use the conjugate. Now, this is 5 plus the square root of 3. His conjugate would be 5 minus the square root of 3. Comes from the difference of squares. That eliminates the center term. So that if I had a minus b times a plus b, this would be a squared minus ab plus ab minus b squared, which is a squared minus b squared, which says that you square each one of these individually so that you don't have a center term. So essentially the relationship here, that oftentimes we don't call it this, but these are conjugate pairs. They're conjugate pairs. So that says if I wanted to get rid of the radical in the denominator, that would be true even if it were in the numerator, is I multiply by the conjugate, which is 5 minus the square root of 3. But I multiplied by 1 because 1 doesn't change the value of the fraction, just changes its appearance. So if I take 1/2 and I multiply it by 1, namely 3 over 3, that's 1. I get 3 over 6. That's still 1/2, but in a different form. So this is 1. So you take 7 plus the square root of 3. You're going to multiply it by the conjugate. 5 plus the square root of 3, 5 minus the square root of 3. This is just 1. Anything divided by itself is 1. You get 7 times that numerator. The denominator, this becomes 5 plus the square root of 3 times 5 minus the square root of 3, which is 25 plus 5 square roots of 3 minus 5 square roots of 3 minus the square root of 3 times the square root of 3. So that these two add to 0. So this then becomes 25 minus the square root of 9, which is where they come up with 25 minus 3. So 25 minus 3 is 22, so you get 7 times that, the conjugate, divided by 22, or you could multiply it through, depends what you're going to do with it. So in this case, the conjugate that I'm going to multiply, because I need to get rid of the radical in the denominator, would be the square root of 7, that's a plus, so this would be a minus. The square root of 7 minus 2, make sure I'm multiplying by 1. So then this becomes the square root of 2 times the square root of 7, subtract 2, over square root of 7 times the square root of 7. The inner is 2 square roots of 7. The outer is minus 2 square roots of 7. And the last is going to be positive 2 times a negative 2 is a negative 4. These add to 0. You get the square root of 2 times the square root of 7, subtract 2, over square root of 7 times the square root of 7, square root of 49 minus 4, which is the square root of 2 times the square root of 7, subtract 2, over square root of 49 is 7 minus 4, or the square root of 2 times square root of 7, subtract 2, all over 3. Can't reduce anything out. This is a perfectly okay answer depending upon what you're going to do with it. You can multiply the square root of 2 through, so it's the square root of 2, square root of 7 minus 2 square roots of 2, all over 3. Square root of 2 times the square root of 7, square root of 14, minus 2 square roots of 2 all over 3. That would be another alternative answer. Either one would be fine, depending upon what you're going to do with it.